1-5 is all about systems of equations. A lot of it is review from even just the summer work a little while ago, but definitely from last year. Where we got pretty good at solving 2x2. We're going to go on to 3x3 systems of equations. And I forgot to write the stuff up there, so I think I will make it appear. Are you ready? Here we go. Hey, there it is. All right. Well, Joe has 41 coins, and they're quarters, nickels, and dimes. So we've got 41 coins in a piggy bank. They're worth a total of $4.60, these quarters, nickels, and dimes. And he happens to have more than 3 times as many nickels as he has dimes. So how do we solve the precise number of nickels and quarters and dimes that he has? Well, you could guess and check for a while, and it maybe would take you a while. Some people are better at this than others, but it's not really a reliable method. Certainly nothing you want to do on a test. You definitely want to go with your algebra skills on this one. So we're going to write 3 equations with our 3 unknowns, and then we'll try to solve it algebraically. So this first one, if Joe has 41 coins, we need to sort of define our variables, and N will stand for how many nickels Joe has, and D will stand for how many dimes he has, and Q will stand for the number of quarters. And if I add up those, it should be equal to 41. That's the total number of coins that he has. Well, the second equation can be written by introducing their value. Well, a nickel is worth 5 cents, so it makes sense that if I have like 7 nickels, that the value I have would be 35 cents. So I'm going to convert everything to pennies and say 5 pennies for every nickel, plus 10 pennies for every dime, plus 25 for every quarter will give me 460 pennies in our cents value. It's a lot easier than going decimal, because so often I'll get kids making mistakes by using 0.5 for a nickel when of course it's 0.05. And then the third equation, if Joe has more than 3 times as many nickels as he has dimes, he's got a lot of nickels. He has even more than 3 times as many nickels as dimes. So why don't you take a shot at writing an equation for that, and you can pause me and I'll just wait patiently here while you go give that a try. But write down that equation and then come back, okay? All right, you did that? I hope you did. Turns out the equation is going to be 2 plus 3D, because I've got to take the small number of dimes and multiply them by 3 and then still add 2 more to be equal to the number of nickels, all right? Well, this is written differently than these because it goes nickels, dimes, quarters, and then the number. So I'm going to do a little bit of work here and rewrite this by moving the 2 over to this side and be -2, and moving the n over to this side and being minus n plus 3d equals -2. All right, if you need to pause it again and work that out on your own, you can do it, but that is correct. By putting these in standardized form like this, it makes it a lot easier to use our calculator in a minute, which we're going to do. All right, so I need to solve these. There's no quarters in this equation, so if I can combine these two to get rid of quarters, I'll have 2 equations, this one and the combined one, and then 2 unknowns, and I can solve that quite easily. So what I'm going to do is I'm going to multiply this top one so that the quarters cancel out by -25. -25, -25, 41 times -25, well, 40 times 25 is going to give 1,000, so it's going to be -1,025, okay? Then when I combine these two by just adding them, this will give me -20n, this will give me -15d, and then this will give me a -565. Okay? Well, I take this and I can rewrite this to cancel. If I multiply this, everything by -20, this will become a positive 20n. Multiply this by -20 and I've got -60d. Multiply this by -20 and I've got a positive 40. Draw a line and I again add. This is our combination method. These cancel out. I get -75d equals a -525. Okay? Okay, I'm back. My battery ran out, so I've got it plugged into the wall. Let's see, where was I? I was adding these guys up, and those cancel, and I've got negative 75D equals then what? Negative 525. So, how many times does 75 go into 525? Well, if you think in terms of like quarters, these are 3 quarters, and this is going to be 21 quarters, so 3 goes into 21 7 times, so D is equal to 7, okay? I can then do what's called back substitution. If I just simply sub this in here for D, I get negative N plus 21 equals negative 2, and by subtracting this from both sides, negative N equals negative 23, well, N then is equal to 23, so I have 23 nickels to go with my 7 dimes. That's a total of 30 coins, but I have 41, so I've got to have 11 quarters then, right there. I'll quickly check our answer. It never hurts to check your answer. That's going to be 70 cents. That is going to be $2.75. Oops. And this is going to be $1.15 in nickels. And that's a 0. Carry the 1. 14, 15, 16. Carry the 1. $4.60. So we're good to go on that. Okay, now I'll show you how to do it on your calculator. But first thing actually I think I'll do before I even jump to that calculator scenario is to go back to this stage of the game and say, take away the black here, and N plus D plus Q equals 41. If I convert this into the way we did last year with matrices, where we just know that this column is all N's, and this column is all D, and this column is all Q's, I can write a matrix form of that 1, 1, and 1, our coefficients here, and then 5 and 10 and 25, and negative 1 and 3, and then I write the 0 there. That's going to be the matrix for that. This then will be the variables N and D and Q, and then this is what they're equal to: 41 and 460 and negative 2. Okay, so I could take each of these rows and flip it and smack it upside this column here and multiply, and I know that those would equal this 41, so I can go back to that equation if I want. But this is what I'll put into my calculator in a moment. And we're going to do that matrix really quick. I just have the matrix key right here, and so I will do second, hit matrix, and there's my menu. I've got names, and then I've got the computations, and I can edit. Well, I want to go to edit, so I do left arrow and hit enter, and you can see this is a 3 by 2. So 3 is going to be good, but I want it to be a 3 by 3, so I type in 3, I hit enter, and then you can see it's made 3 columns by 3 rows. And then I just want to enter those values, which you'll recall are 1, 1, 1, and then the next one is 5, 10, and 25, and then the next one is negative 1, 3, and 0, and that's my first matrix. Well, that's matrix A. I do second and matrix again to get back, and now I'm going to go over to edit, but then down to the second matrix, and I hit enter, and I want this to be a 3 by 1, so I type in 3, and I can do enter and enter, and now I've got just the 3 in one column, and I type in 41, and then 460, and then negative 2, and I'm good. That's all it takes. If I quit out of that and then go back to matrix, and I simply choose this first one, but then I inverse it, so I hit that inverse key, and then I go back to matrix and I choose B by just pressing 2, and then hit enter, and that will give me my solution right there: 23, 7, and 11.